Hello, I'm Ms. Nichols, and this video lecture is on variables, units, and operators. For every video or lecture, we're going to have an essential question, which is something that you should write on your Cornell Notes page in your notebook. And the essential question for this video is, what are variables, units, and operators, and how do I identify or use them? So one of the things about these video lectures is you can always pause to write things down if I'm talking too fast. You can always go back if you miss something. And I'm going to really encourage you to not just write down the words on the slide, but also to listen to what we say and to process and try to put things in your own words the first time, because that's a whole lot of the work of the learning, is just actually thinking about what you hear or what you read and writing it down in your own words. Okay, so a variable is anything in the world that has a scientifically measurable, numeric, which means a number, value that can change over the course of time. I made this helpful chart to give you some examples of things that were not variables and things that are variables, because in my experience, being able to determine whether something is or is not a variable is one of the challenges that many ninth graders face in this class. So a dozen, for example, that is not a variable. And the reason it's not a variable is because while it does have a numeric value, a dozen never changes over time. It's always 12. It always has the same value. So therefore, it's not variable because it's not changing. Your brother, or frankly, any noun, any object that you can see in the world around you, is not going to be a variable either. And the reason is because those aren't numbers. They're not values of things that are going to be changing over time. They are people. In physics, we often are interested in the topic of the problem, but we're not going to, it doesn't matter in the problem whether it's your brother or a sister or a chair. Okay, the physics of the problem doesn't depend on what the object is, so they're not going to be variables. Another thing that some people often confused with variables are like opinions about things. So how good a pizza is, if I ask you on a scale of 1 to 10 how good a pizza is, you may be able to give me a numeric value, and that value may change over time, or it may change as you have different kinds of pizzas. But what you're missing is the scientifically measurable part. Because since that's an opinion, not everybody is going to agree on how good a pizza is, it's not a variable because we can't measure it using a scientific tool. So some examples of things that are variables. Your height is a variable, and the reason is because we can measure it using a meter stick. We can give a number to your height, and it may change over the course of time. The speed of a car could be a variable, because again, we can use the speedometer to measure that speed. It gives a number, and that speed might be changing as your car goes on a trip over time, faster sometimes and slower sometimes. Another example of a variable is the amount of money in your wallet. Like, we can scientifically measure that by counting it. It will have a numeric value, and that value will likely be changing over time as you get more money or spend money from your wallet. So while I give you lots of examples of variables, in physics there are a subset of very special variables known as the fundamental variables. And these are the variables that physicists can use to describe everything in the entire universe just based on combinations of these 6 different fundamental variables. So these are the ones we're going to be using primarily in this class. The first one is time. Okay, so how long something takes, and of course we'd use a clock to measure that. The second is distance, how far apart things are, and we are going to of course use a meter stick or a ruler to measure that. The third is known as mass or energy, and we have scales or other tools for measuring those things. The fourth variable is called charge, and you may have heard of that before if you've studied a little bit of what's going on inside of an atom. We'll do more of that in this class later on. And the last 2 fundamental variables are good topics for advanced level physics. They're known as color and spin. They're not what they sound like they are quite. They're ways of measuring properties of really, really, really tiny objects. So in any case, but those are the 6 fundamental variables that we'll be using. And pretty much every other physics variable in this class is actually some combination of those variables multiplied, divided, added, subtracted from each other. So it's really worth our time to understand those first 4 variables in this class. So every variable is going to be followed by something called the unit, or the units of the variable. And these units, which is like a little set of letters or numbers or a short word after a number, give that word meaning and size in the real world. The other thing that we use units for a lot in physics is if we have a word problem that we're reading and there's like a sentence about some stuff, the units of a number in a sentence can help us figure out what the heck it's talking about. So for example, if you read a word problem and it just said, I'm going to give you 6, you'd hopefully say to yourself, 6 what? What are we even talking about in this problem? So you're missing in that the unit. The unit is the magic little thing after the 6 that tells me what exactly we're talking about. Hopefully that problem was talking about something like candy. Now you'd be really happy if that problem was, I'm going to give you 6 bags of candy. But so the candies in that case is the unit. Of course, it could have been 6 bags of dog poop, and that would have been a lot worse of a problem to be reading about. So the units in this case are the description after the number that tells you what we're talking about. So I want to introduce you to some of the most common physics variables that we'll be using. We already talked about the fundamental variables. Some of these are those, and some of them are combinations of those. And for every variable, there's also what's called a symbol. The symbol is like the shortcut. The physicists are really lazy and we don't want to write the whole word for some of these variables. And then there is also a variety of different units that could all apply to that variable. And these should be pretty familiar to you once I start going through them. So the first variable that we'll deal with is time. Time is really relevant in physics. Of course, we got to understand time to know how the world's going to work. And the symbol that we use to represent time in an equation, or just if we don't want to write the whole word, is a lowercase t. The units for time are anything that you would normally measure time in. So seconds, hours, minutes, years, months, eons, those are all possible units for time. The second common physics variable is distance. Of course, distance is basically how far apart things are. And in physics, we, in this class, are going to use the symbol lowercase d, so a little d, to represent distance. And common units for distance could be meters, if you've seen a meter stick before in a science class, could be inches, could be miles, so there's lots of different possible units for distance. A third common physics variable that's going to come up in this unit is mass. And mass is going to be kind of like how much stuff is in an object or how heavy it is. We'll talk about it more later on, but you probably have a sense of what mass means. It's kind of like weight, not quite the same, but similar. And the symbol for mass is going to be lowercase m. And we are usually going to be measuring mass in this class in a kilogram, but you probably have heard mass measured in pounds or grams or ounces before. And the fourth common physics variable that I want to introduce is called energy. We're going to be dealing with that more in the next unit, but I wanted to put it in your notes early as well. We are going to use a capital E to represent energy. And while you probably have not done a lot of measuring energy in your past before, you've probably heard of a calorie. And when you look at food and the labeling on food, the amount of energy that's stored up in that food is going to be measured in how many calories it has. There is another unit for energy known as the joule as well. In that list above, all of the units that were yellow are known as the SI units, which are like the scientifically accepted units that if you read a scientific journal or publication about something, those are the units that they'll use. And so those are the ones we're going to probably use primarily in this class, the yellow ones. One little note about units, you should be able to convert or change any units into other units of the same variable. So, right, if I give you an amount of time measured in hours, you could also tell me how many seconds that is, or how many minutes, or how many years, right? So that's converting from one unit to another without changing the variable. And you can do that with any of the variables. And we're going to be learning how to do this. The last big slide in this slideshow is about what's called a mathematical operator. So a mathematical operator is like a special symbol. It's not usually a letter or a number. It's like something different that tells you to perform a specific math operation on a number or variable in your equation. You're familiar with quite a few math operators. Of course, you know what plus means. It means add the two variables together, or that little symbol means take the square root of something. You may have seen greater than, less than, which means to compare two values. In our class, we will use all those, but we're also going to have some special physics ones that I want to make sure that you are familiar with. So one thing that we do to variables a lot is we give them what's called a subscript. So if you have a variable but you want to be specific about it, you can write another little letter or number. So sub means below. This is like a little letter or number that is below the variable that tells me something specific about that variable. So for example, if you had a math or physics problem about a bag of cookies and it had a mass of 0.7 at the beginning of the day, 0.7 kilograms, and a mass of 0.4 kilograms at the end of the day, if you wanted to write down all the variables that are in that problem, the tricky thing is those are two mass variables, and so you don't want to just call it mass and mass, or you're going to be confused about what you're talking about. So what a physicist would do is they would write M, and they're going to put this little subscript I, right? So that's the subscript, and then I would write the value of that variable, which is 0.7 kilograms. So that little subscript, the I, stands for initial, or the starting mass of the object. If I wanted to write down the other variable, I would write M with a little subscript F, and the F stands for the final value of that mass. So you can keep those variables separate from each other by using the little subscript to kind of identify what's going on. If you had like mass of a person A and person B, you could do M sub A or M sub B. Any of those little subs are just ways to identify what's really going on. Another math operator that you may be familiar with, but probably are not, is known as delta. And the delta operator means that we have a variable whose value is changing. Something is happening to this variable over time. It's going up or it's going down. And we actually don't even care what the value of the variable is. We only care how much they change. There's a lot of times in physics where we care about what's changing and not just what actually is. So for example, if you had a problem that had a dog and it was starting running at 12 o'clock and it ended at 12:45, in terms of physics, I don't really care if this is happening at 12 or 12:45. The dog's moving. I don't care if it's happening at 2 a.m. The thing that's going to matter in physics is basically how long the dog was running for, how much time passed between the beginning and the end. And that's a delta because something is changing, right? We're changing time from a certain time to a final time, and we don't really care what those times are. We just care about how much time passed in the middle. So that delta means how much a variable changes by. In this problem, my initial time would be 12 o'clock, my final time would be 12:45, but my delta t, or change in time, would be 45 minutes, and that's probably going to be the most interesting variable that you can get out of that statement, and the most useful one in terms of physics as well. So delta is how much a time changes by. There is a little equation you can use. Most of us just sort of think logically about how much something is changing, but if you like to have like a procedure to calculate change, it's going to be the final of whatever minus the initial. So in this case, your final time is 12:45, subtract your initial time, which was 12 o'clock, and you're left with your 45 minutes. One note about delta. Delta of anything can be 0 if the variable's value isn't changing. So if you start the day with $9 and you end the day with $9, your delta money is still 0 because nothing has changed from the beginning to the end. So delta can have a 0 value, and delta can also have a negative value. So same example, if you started with $9 and you end the day with $6, your delta money is going to be -3 because your money went down. And so a negative delta reflects the fact that a variable is becoming more negative or going down. So another operator that maybe you've seen before, but probably not, is known as sigma, and it kind of looks like that funky E with some angles added to it. If you see the sigma symbol in a problem before a variable, it means that we're actually interested in the total or the sum. So sigma means sum, which is like add all of the values of that variable together. So for example, if you had 4 people that each had $10, The sigma money, or whatever variable you're using, would be $40. It would be adding up all of those things together. The last math operator to talk about going into the year is known as average, and this is one that probably you have experienced in a math class before at some point. We're usually just going to write AVG because that's a little easier than writing the whole word average. And we usually use it as a subscript. So if you see the subscript AVG, it means that this is some variable that's changing over time. We don't care where it started or where it ended or even how much it changed by. What we care about is what the average or central or typical value of this variable is. So for example, if you have a car driving out of state somewhere and you start at 40 at the beginning of the trip, 40 miles per hour, and you end up speeding up to 50 miles per hour, you might want to know what the average speed over the course of the trip is. And it's not quite as simple as this, but in general, it's like the value right in the middle, right, in this case. So the average value of 40 and 50, the value right in the middle is 45. There is also an equation for calculating average that you probably learned in an earlier math class. You can always calculate the average of two numbers by adding them together and dividing by 2. So in this case, it would be 40 plus 50, which is 90, divided by 2, which gives you 45. So you can either think about just finding the number right in the middle, or you can think about adding together the two numbers and dividing by 2 to get the average. Okay, we've reached the end of this video, so I'd like you to take a few minutes and answer the essential questions. So make sure that you could write down in your own words, what are variables, units, and operators, and how would you identify them, and why would we care? And then also in the side margin of your Cornell notes, anything that was unclear, any questions you have, anything you're not certain about, or any ways you can connect with this material, like, oh, I learned about this in 4th grade, or probably not 4th grade, but, is that average really going to work if, whatever it is, whatever questions you've got, please jot them down so that we can talk about those in class. At the end of every slideshow, I always like to leave you with a Calvin and Hobbes or another comic that somehow connects with this. So here you are. I hope you enjoy.